Hello and welcome to edupediaworld.com. Friends, today we are going to start with the chemical state of matter. But first let's revise what we have done in the last session, that we had learned the physical state of matter, that was solid, liquid, gas. We learned molecular properties determines the state of the substance. Matter can be changed from one state to another by heating, cooling or changing pressure. All substances cannot be changed from one to another state, like sugar. After heating, it decomposes itself. We learned kinetic molecular theory, that was particles of any substance are in a continuous movement. We also learned that kinetic energy of the particle increase on heating. Thus, the motion of particle increases. We learned that liquid and gas are called fluids. Yes, the solid is the rigid form of the matter. Now today in this session we'll be studying element, compound and mixture. Friends, so let's see what the chemical properties says. We learned that the matter, every matter have pure or impure substances, like pure, and this is impure. Impure, we understand elements and compounds. Impure is mixture. Now, what is pure and impure? Just take an example. If you have a bag having potatoes, only potatoes, we call it element. We have another bag with the potatoes and onions, we call compound. That is potatoes, we have potatoes plus onion. There's a one more bag which have potatoes, chili, onion, some tomatoes, some take brinjals, but not in a proportionate form. That is not in a equal form or not into any, like any distributed form. It is just randomly the bag having all these things. And if we say in the compound, it is very distributed or proportionately carried, the potatoes and onions in the bag. Now we see the element, we have only potatoes in that bag. That means all same items is a combination of two or three items in a very proportionate manner. And in mixture we have many items or many vegetables in the bag without any proportionate manner or without any um, weighted manner. What you say is like counted manner. So it's a impure thing. Impure in the mixing of many things. It is, and compound is mixing of two or three things in a very accurate or proportionate or calculated manner. In elements, it have only one kind of matter, or say any one kind of element, atom, what we call as atom or molecules. There is only one kind of which forms element. Now let's see first what is element. I hope you have understand the meaning of pure and impure. We have pure, we have element and compounds, and in impure we have mixtures. So we are going to start with element, compound and mixture. In this session we are not going to into deep detailings of all these trees. We are only briefing out. In further sessions we'll be discussing in very detailed manner, like this you have seen. Okay, so let's check out the element first. Friends, what is element? Yes, as I have told you, element is one kind of made one kind of atom or say molecule. If we see dramatically, it is an element. It is made of atoms or called molecules. See, atoms means small, same size of same kind of atoms forming a element. Or this can be grouping of what is molecule? Molecule is nothing but grouping of atoms. Point to be noted, grouping of same kind of atoms form a molecule, a group of atom called molecule, which form a element, right? Now if you see the characteristics, what are the characteristics of element? First, we have said it is a pure substance. Yes. For example, hydrogen, oxygen, or we say carbon. Second, it is formed by same kind of atom, right? Third, we say it is a homogeneous substance. What is homogeneous? Homogeneous means make of one kind. Fourth, we can say it has its own fixed melting and boiling point. Or say it cannot be broken down into the further. Yes, it is continued. I saw that is an element cannot be broken down in further by any physical or chemical processes. As we know that as an atom is a very smallest particle of an atom, as an element, it takes part in chemical reactions too. Yes, it like element plus element, if you say, can form a compound, right? So from this description or with this briefs, we should know what is element now. Let's read it out. Like what is element? If you define, it is an element is a substance which cannot be split out into two or more simpler substance by usual chemical method of applying heat or electricity or any kind of chemical or physical reactions. Now, how do we represent element? Yes, we have a kind of a symbol of any element. We cannot write hydrogen every time we are using that element in the chemical reactions. We have to use the symbol. That is, what is a symbol? The symbol of an element is the first letter or the first letter or another letter of the English name or the Latin name of the element. For example, the symbol of hydrogen, we take it as H. The symbol of oxygen is taken as O. Now, if we just read it out, an element do have atomic number, atomic mass. As we see in many things like for example, we take hydrogen, right? Here in the periodic table, here we write atomic mass, and here we write atomic number, right? What is atomic mass? We'll be going to details in the further sessions. Just to make you clear, what is atomic mass? Atomic mass is the number of proton plus neutron. What is atomic number? It's a number of proton. Note, what is proton? Proton is into the atom. It presents in the atom. It is basically the positively charged particle lies in the nucleus of atom, right? So what is atomic number? It is the number of protons which forms the atomic number. And what is atomic mass? It's a number of proton and plus number of neutron. So we write like this. An element has been writing like this into the periodic table, which have the group of all the elements which we know is formed into the table. So we read out atomic number of an element is defined as the number of proton present in the nucleus of atom of a particular element. And what is atomic mass? Is the mass of an atom of chemical elements expressed in the atomic mass unit. It is approximately equivalent to the number of proton plus number of neutron in an atom. So what is the significance of why do we write symbols, right? What is the significance of symbols of element? Yes, it represents the name of the element. It represents one atom of the, this is very important, it represents the one atom of the element. The symbol represents 1 mole of atom of the element, that is 6.023 into 10 to the power 23 atoms. It represents definite mass of the element. It also represents a definite mass of element measured in grams. So yes, from now onwards you should know the importance of symbols. Now let's come up to the compound part. So as we know, one or more element form a compound that we, in the layman, we write element plus element is equal to compound. But the thing is, it is not just adding two or three or mixing of two or three elements and making a compound. It's coming together two, three elements in a very, very proportionate weight, right? So like we say that dramatically if I tell you a compound is like, let's see, this is a molecule part. There's two, three different kinds of molecules present. It's a molecule. So I'm so sorry. This is an ions. Like for example, let's see, it is a water molecule. That is, water is an compound itself. Let's say it is sodium chloride. So these are two kinds of compound. One is molecules or one is ions, right? So if we see, take the definitions, we can clearly see that yes, it is also a pure substance. If we segregate compound, we call it organic. Second is inorganic. Organics are those which have a carbon in it. That is, all the carbon compounds are organic compounds, and rest are all inorganic compounds. So we say it is a pure substance composed of two or more elements combined chemically in fixed proportions. A very important point, in a very fixed proportion. The properties of a compound are different from properties of its constituent elements. Like for example, the character, let's write first, characteristics of compound differ sticks of elements which are the constituent elements. Like if you take an example, like for example, if you take example of water, this is a hydrogen, this is oxygen, and this is a compound, water. Now the characteristics of hydrogen is different from the characteristics of water. Both are different. Yes, oxygen is having their own different characteristics. So these two are elements and this is a compound having a fixed proportionation of mass. So friends, from this concept you have the idea of what is compound basically. Now let's just read out the properties and the definition of compound. Yes, a compound is a substance made of two or more elements chemically combined together in a fixed proportion by weight. What are the properties? Yes, it cannot be separated by physical method. Yes, it can be separated by chemical methods, but not by physical method. The properties of a compound are entirely different from the individual properties of constituent element. As I told you just right now, the heat is usually either absorbed or released in the preparing of compound. That is, in further sessions we'll be discussing about exothermic or endothermic reactions. The composition of compound is fixed in a fixed proportion. That is very important, which makes the difference between the compound and a mixture. Now come up to the mixture. Let's see, understand it with the examples. We all have know that air is composed of many and many gases, right? It have many elements, dust particles, it have oxygen in it, it have nitrogen in it, there's carbon dioxide. Yes, it is a compound in a gaseous form. We have many other smoke, you say. We have many more things in the air. So the air is basically a mixture. The question arises why why we call air as a mixture. Why air has been defined as an example of mixture. Why? We should know that the mixture, as I told you earlier also in previous sessions, that the mixture is not, but it is a mixing of many substances or many one or more than two, three substances which are not chemically combined with each other. They are just having themselves in that particular thing. If, or say in other words, if you say that the matter composed of two or more substances whose particles are basically in the contact but not in a chemically combination, that is not chemically combined together, they basically have lost their own individual properties, right? So if we see the characteristics, that is first we have understand that they are not chemically combined and the individual particle lost their own properties, so it's a impure substance. As I told you, very lay example of a bag having a many kind of vegetables in it, but they are not in the proper proportionate, or you can say by weight. Second, if you say it may or may not be homogeneous. What is homogeneous? Of the same kind. Or if you see what is that, it can vary in proportions, that all the components in proportions. Or in other words, we can say the melting point and the boiling point of a mixture is not fixed, right? And one more thing I should tell you, that there is a no energy exchange when during the formation. Of mixture. We are not going to the details of the mixture. In further sessions, we'll be going to detailings. So let's read out quickly. That is, what is mixture? It is a matter composed of two or more substances whose particles are not in contact but are not chemically combined also, and have not lost their individual characteristics. What are the characteristics of matter? Yes, it consists of two or more substances that exist together without any chemical force. It may or may not be homogeneous or heterogeneous. What is heterogeneous? Heterogeneous of different kinds. It can have its component in varying proportions. It can be separated by physical methods. Yes, the this point differs. The mixture differs from compound. That compound cannot be separated by chemical reactions or chemical methods, and this mixture can be separated by physical method, right? That is, a compound cannot be separated by physical method, and this can be done. It can be separated by physical method. Usually no energy exchange takes place during formation of energy. So yes, now we conclude the session with the chemical combinations of matter. That is, first we call it a element. That these are the first, A is an element which says when every atom in a sample of matter is exactly the same, that is a pure, the molecular structure doesn't matter. Iron, sulfur, copper, gold, anything on the periodic table is an element. Now we come to the second part, that is compound. When every molecule in a sample of a matter is the same. Here it's a difference when every molecule in a sample of a matter is the same. They are considered pure substances. Elements and compound are considered as a pure substance. The molecule must be made of two or more elements. The constant ratio of element is created and are represented in the chemical formula. We can have an example like water, carbon dioxide, CO2, sugar, C6H12O6. Now last but not the least, that is a mixtures, which differs from all these the rest tools, that there are at least two different atoms or molecules that are not the same. That is an impure substance. No chemical formula. They have the ability to separate physically. That is a physical method can be used to separate them. Example is air, salty water, or any food ingredient. We can see the pictorial form. Now, friends, let's have an activity. You have to spot the figures. There are three figures. One is mixture, second other compound and elements. You have to spot the figure in 5 minutes. Thank you. Now in next session, we'll be studying kinetic molecular theory of gases. Thank you. Thank you, students.